What effect does your race have on your chances of having a mortgage application granted? Holding constant other factors, such as your ability to repay the loan. What effect does a 1% increase in the price of cigarettes have on cigarette consumption? Holding constant the income of smokers and potential smokers. The multiple regression model and its extensions provide a framework for answering these questions using data and for quantifying the uncertainty associated with those answers. 1.2 Causal effects and idealized experiments. Like many other questions encountered in econometrics, the first three questions in section 1.1 concern causal relationships among variables. In common usage, an action is said to cause an outcome if the outcome is the direct result or consequence of that action. Touching a hot stove causes you to get burned. Drinking water causes you to be less thirsty. Putting air in your tires causes them to inflate. Putting fertilizer on your tomato plants causes them to produce more tomatoes. Causality means that a specific action applying fertilizer leads to a specific measurable consequence, more tomatoes. Estimation of causal effects. How best might we measure the causal effect on tomato yield measured in kilograms of applying a certain amount of fertilizer, say 100 grams of fertilizer per square meter? One way to measure this causal effect is to conduct an experiment. In that experiment, a horticultural researcher plants many plots of tomatoes. Each plot is tended identically, with one exception. Some plots get 100 grams of fertilizer per square meter, while the rest get none. Whether or not a plot is fertilized is determined randomly by a computer, ensuring that any other differences between the plots are unrelated to whether they receive fertilizer. At the end of the growing season, the horticulturalist weighs the harvest from each plot. The difference between the average yield per square meter of the treated and untreated plots is the effect on tomato production of the fertilizer treatment. This is an example of a randomized controlled experiment. It is controlled in the sense that there are both a control group that receives no treatment, no fertilizer, and a treatment group that receives the treatment 100 grams per meter squared of fertilizer. It is randomized in the sense that the treatment is assigned randomly. This random assignment eliminates the possibility of a systematic relationship between, for example, on how sunny the plot is and whether it receives fertilizer, so that the only systematic difference between the treatment and control groups is the treatment. If this experiment is properly implemented on a large enough scale, then it will yield an estimate of the causal effect on the outcome of interest tomato production of the treatment applying 100 grams per meter squared of fertilizer. In this text, the causal effect is defined to be the effect on an outcome of a given action or treatment as measured in an ideal randomized control experiment. In such an experiment, the only systematic reason for differences in outcomes between the treatment and control groups is the treatment itself. It is possible to imagine an ideal randomized control experiment to answer each of the first three questions in section 1.1. For example, to study class size, one can imagine randomly assigning treatments of different class sizes to different groups of students. If the experiment is designed and executed so that the only systematic difference between the groups of students is their class size, then in theory this experiment would estimate the effect on test scores of reducing class size, holding all else constant.